Welcome to Shaping the Digital Library, Advances in Information Retrieval, presented by AI Frontiers. In this episode, we explore highlights from 73 papers published in late September 2025. The focus is on how search, recommendation, and fairness are shaping our digital experiences and driving innovations in information retrieval. We'll also spotlight Liu et al.'s work on fairness in recommendations. Every second, Google processes over 99,000 search queries, nearly 6 million questions in the time it takes to brew a cup of coffee. Behind each query, algorithms and models race silently to deliver the right answer, instantly. Information retrieval, or IR, powers not only search engines, but also recommendations and digital assistants. The same technology that helps find the best ramen shop nearby also shapes the way society accesses knowledge. Consider, your next favorite song, discovery, or insight could be just an algorithm away. Information retrieval profoundly influences what we see, hear, and learn online. It underpins search engines, recommendation systems, and virtual assistants, determining the information landscape for billions. The field faces ongoing challenges in fairness, scalability, and maintaining user trust. Recent research addresses both technical and societal questions, striving for systems that are not only effective but also equitable and reliable. The goal of this session is to unpack the latest trends and breakthroughs that define the current state of information retrieval. Picture a massive, chaotic library containing every type of media, books, images, music, social connections, and conversations. Information retrieval functions as a smart librarian, expertly sorting, filtering, and recommending relevant materials. Its capabilities now extend far beyond text, encompassing a wide spectrum of digital content. The central challenge remains: delivering the right information to the right person at the right time. Technically, this involves relevance ranking. Systems measure and prioritize what matters most to fulfill user needs. The boundary between search and recommendation is dissolving, resulting in unified systems. Yan and colleagues, through their IntSR framework, employ deep generative models to provide integrated suggestions. This approach is akin to a cafe barista who anticipates your preferences and introduces new favorites. These modern systems increasingly predict user needs before any explicit request is made. At the core are deep generative models, advanced algorithms capable of creating new data patterns based on extensive learning. Modern information retrieval now integrates text, images, audio, and structured data within a single framework. Xiao and colleagues' meta-embed system scales to 32 billion parameters, enabling flexible trade-offs between retrieval speed and accuracy. Much like a Swiss Army knife, meta-embed adapts to any information type, facilitating richer and more expressive search experiences. The use of multimodal embedding serves as a bridge, connecting diverse forms of data for comprehensive retrieval. As information retrieval systems become more influential, scrutiny regarding fairness has intensified. Bagway and colleagues' bias RAG framework uncovers latent biases within retrieval-augmented systems. These systems, much like referees in high-stakes games, are expected to be impartial and transparent, yet biases often persist undetected. Attacks and manipulations can subtly alter what users are shown. Consequently, robustness and transparency have emerged as central research priorities in the field. Recent research presents several key findings. Li and collaborators demonstrate that upweighting power niche users, those with high activity and unique preferences, reduces popularity, bias, and enhances content diversity. Xiao et al.'s meta-embed allows scalable and flexible multimodal retrieval. Bagway et al. Highlight fairness vulnerabilities through bias RAG attacks in IR systems. Yang and colleagues' contextual retriever leverages dialogue context to improve conversational search robustness. Additionally, Zhang et al. Show that synthetic query rewrites, generated by large language models, can sometimes surpass human-authored versions in retrieval-augmented systems. Liu and colleagues address the persistent issue of popularity bias in recommendation systems. This bias often results in mainstream content, overshadowing unique niche items. Their research focuses on power niche users, individuals who are not only highly active, but also exhibit distinct, non-mainstream tastes. By recalibrating the influence of these users in the recommendation process, the framework surfaces hidden gems. The approach enhances the classic Bayesian personalized ranking, or BPR, loss function by introducing interpretable parameters that adjust user influence, thereby improving fairness in recommendations. The methodology involved segmenting user item interaction data along axes of activity and preference. Interpretable parameters were introduced to amplify the impact of power niche users. The framework achieved both a reduction in popularity bias and an increase in user satisfaction with recommendations. Importantly, this method can be integrated seamlessly into existing recommendation systems. The result is a Pareto-dominant improvement. Both diversity and accuracy are enhanced, with no necessary trade-offs. The motivation behind Liu et al.'s work arose from a concern with the repetitive nature of algorithm-driven recommendations. Their research illustrates that technology, when thoughtfully designed, can amplify diverse voices, not only mainstream perspectives. The team navigated challenges including complex data calibration and skepticism from stakeholders. The solution is practical and readily deployable, offering real-world impact. Ultimately, this work broadens the horizon for fairer and more engaging digital recommendation platforms. The future of information retrieval can be envisioned as a living ecosystem, much like a river that adapts its flow. Next-generation IR systems will sense and respond to shifts in user behavior in real time. Multimodal architectures will facilitate seamless translation between various data types, enhancing comprehension and relevance. User simulations powered by large language models will reflect, instruct, and empathize with users. Achieving fairness and trust in these systems will require the development of new tools and increased interdisciplinary collaboration. In summary, information retrieval is evolving rapidly, integrating search, recommendation, and fairness into unified solutions. Researchers such as Liu, Xiao, and Bagwei are at the forefront, addressing both technical and societal challenges. The field's trajectory points toward greater inclusivity, transparency, and adaptability. To gain deeper insights, listeners are encouraged to explore the referenced papers. Participation in ongoing discussions and research is vital for shaping the future of information technology. This presentation was synthesized using GPT 4.1 from OpenAI for narrative construction and analytical insights. Speech generation was accomplished with Deepgram TTS, and visuals were designed with Grok AI. Human experts reviewed the content to ensure clarity and accuracy, though minor oversights may remain. Refer to the included paper citations for verification. All references are provided to support further reading and scholarly inquiry. Stay curious with AI frontiers. Subscribe for in-depth explorations of the latest AI research and join a community dedicated to the future of information. Find us online at the AI Frontiers channel. Thank you for supporting research-driven discovery. Keep searching, keep asking, and stay inspired. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.